Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 13 from module 2, and it's called Angle Sum of a Triangle. So, concept development, we have three triangles here. Angle 1, angle 2, and angle 3 in this triangle are all less than 90 degrees, so this is an acute triangle. Angle 5 here is greater than 90 degrees, so therefore this is an obtuse triangle. And angle 8 is 90 degrees, so this is a right triangle, because this is a right angle. So no matter what, if you have an acute triangle, or an obtuse triangle, or a right triangle, if you have a triangle on a flat plane, then the sum of the measures of the angles is always 180 degrees. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. Okay, notice this equal sign here. These three angles equal the sum of the measures of angle 4, 5, and 6, and there's another equal sign there. And then finally the measures of angle 7 plus the measures of angle 8 plus the measures of angle 9. All they're saying here is that this triangle, and this triangle all equal 180 degrees when you add up their angles. So it says, note that the sum of the measures of angles 7 and 9 must equal 90 degrees, because the known right angle in the right triangle. Okay, so what they're saying here is, if I know this is 90 degrees, and the sum of the angles of a triangle are 180 degrees, then if angle 8 is my right angle, then these two angles, since this is 90 degrees, 180 degrees minus 90 degrees equals 90 degrees. And that means that the other two angles, angle 7 and angle 9, are complementary. Okay, that means they add up to 90 degrees. Okay, so there's a little info about triangles, or review. Acute, obtuse, right, they all add up to 180 degrees. Okay, so here's an exploratory challenge. Let triangle ABC be given. On the ray from B to C, that's right here, take a point D so that C is between B and D. So here's C, here's B, here's D. It is between them. So all they're saying is extend the side BC in a straight line out. So this BCD is a straight line. And they put D out here beyond C. And that's all that first sentence says. Through point C, draw a segment parallel. Okay, through point C, draw a segment parallel to BA, or AB. So I've said it before, and I'm going to say it again. You just use like a little arrow thing to indicate that these two lines are parallel. Okay, and there's some important concepts that come from parallelism. So A says, name the three interior angles of triangle ABC. So I'm going to start at the top. This is angle A. So there's the name of the first one, angle A. And then if I come over here, this here, so this was angle A. This is angle B. And over here at C, I cannot name that angle C. And the reason is, if I just call that angle C, I'm not telling the reader that I'm talking about this angle. I could be talking about this angle. I could be talking about this angle. Or I could be talking about the whole thing. So there are 1, 2, 3, and then the entire 4. Or I could be talking about this angle. There's 5. Or I could be talking about this angle here. That's 6. Okay, so there are actually 6 angles at C. So I cannot just simply call it angle C. I've got to name it using the two sides that create it. So I'm going to start here. So it's angle B. I'm going to come over to C. So the next name letter is C, and then I'm going to go up to A. So when you're naming an angle where there's more than one angle at a vertex, then the middle letter must be that location, and then the other two have to be on either side of it. I could have also called the angle ACB, but I do need to use 3 letters to name that. Okay, now it says to name the straight angle. Straight angle's right here. Again, I just explained that I cannot name it just C because of those, there's 1, 2, 3, 4, 5, 6 angles there. So I need to use all 3 letters. So this line starts at B, goes through C, and ends up at D. So I'm going to name that angle B, C, D. I could also name it the other way around, angle D, C, B. Part C. What kind of angles are angle ABC? So angle ABC, angle ABC is acute. It's less than 90 degrees. Angle ECD is acute. Okay. But that's not what they're talking about here. And I know I'm going to get those answers when I ask in class. But angle ABC is acute, angle ACD is acute. What kind of angles are they with respect to each other is what that should say. So what they are trying to ask us is angle ABC and angle, oops, I said A, it's E. Let me fix that. That's ECD, ECD. Okay, so angle ECD. So what they're saying is these two angles here, angle ABC and angle ECD, well, since these lines are parallel, BCD is a transversal. And since I can do a translation along this vector and move angle B over here, then it is going to be congruent to angle ECD. So I can say that angle ABC is congruent to angle, oops, not less than or equal to angle ECD, because angle measures are preserved by translations. But there's a name for these two angles, and if they're on the same side of the parallel line and they're on the same side of the transversal, then they are corresponding angles. So there's a lot to know in geometry. A lot of terms. So this is acute, this is acute. They are congruent to each other because they are corresponding angles. What does that mean about their measures? Well, I've already answered that part of the question. Their measures are equal because they are congruent. D. This is what kind of angles are angle BAC? So here's B, here's A, right here. BAC and angle ECA. Angle ECA is right here. Okay? So they're both angle ECA. Oh, I'm sorry, that's out. They're not talking about that. They're talking about this angle inside. Okay, right here. Angle ECA is right here. ECA and angle BAC. Well, this is a parallel line here, and this is a parallel line. So I'm going to bring my ruler down to really clarify this. All right, so if I put my ruler on this diagram, all right, so if I just draw a line through here like that, then you might be able to see it better. This line is parallel to this line, and now this is a transversal, and this is on one side of the transversal, and this is on the other side, and they're in between parallel lines. So if those continue, they'd go all on forever, and those are called, they alternate sides. Alternating means to go back and forth from side to side. Alternate, and they're inside the parallel lines. They're not outside. So if I drew a line here and a line here, they're in between. They're inside these two parallel lines, and they're on opposite sides of the transversal. So those are called alternate, interior, angles. And yes, they are acute, but that's not what they're asking, but they are also acute. And it says, what does this mean about their measures? Well, if I were to put a dot right here and rotate this angle around that dot, it would end up here on a 180-degree rotation, and rotations preserve angle measures, so therefore the measure of angle BAC is equal to the measure of angle ECA. Or I could just simply say angle BAC is congruent to angle. It's not a very good angle symbol. Okay. Is congruent to angle ECA. All right. So if I say the measure of, I can say they're equal. Their measures are equal, but the angles aren't equal. They're in different locations, but they're the same measure. Then we can say they are congruent. Okay. E, what do we know about measures of angles? Now notice how they have the letter M there. We're talking about the measures. We know that the measure of angle BCD, where's BCD? Unfortunately, I have to scroll to see all this. And let's get rid of all of this diagram markup and start fresh. It's getting a little cluttered. So if I clear that all out, and now we're going to talk about the diagram again. Okay. We know that the measure of angle BCD, okay, that's this straight angle right here, is equal to the measure of angle BCA plus the measure of angle ECA, so ECA is right here, plus the measure of angle ECD or DCE, and they called it ECDs, that's okay. So what they're saying is these three angles add up to 180 degrees because they form a straight line. It says to use substitution to show that the measures of the three angles, interior angles of the triangle have a sum of 180 degrees. So it says to use substitution. Okay, so this is going to be a little tricky for you, but because this is the first time we've ever seen this. But what they're talking about is now we have to use our rules and we have to prove that these three angles add up to 180 degrees in the triangle. So they're talking about this triangle right here, and we want to prove that this angle and that angle and that angle will make this 180 degrees. Since this is a straight line, so what we can use is the rules that we just talked about. Since this angle here and this angle here are alternate interior angles, and if I do a 180-degree rotation about that midpoint of AC, then this angle will land right there. So this angle is congruent to that angle. And then this angle over here with 3 marks, ECD, is going to be congruent to angle ABC because they are corresponding angles, which is part C. So since these correspond, they are congruent because of a translation, then angle ECD is going to be congruent to angle ABC, and I now have this one angle that was this angle already here. This angle here is now here, and this angle here is equivalent to this one here, and since these three add up to 180 degrees, then these three must. So let me use letters or numbers to explain that. So if this is 40 degrees, and this is 80 degrees, that's 120 degrees, then this would have to be 60 degrees to add up to 180. So if this is 80, this has to be 80. And if this is 60, this has to be 60 degrees. So then when I get rid of everything outside the triangle and we just focus on this triangle that they're asking us to do, then we see that 40 plus 60 is 100, and 100 plus 80 is 180 degrees. So I can take those three angles that make a straight line and make them congruent by rules to the angles inside the triangle, and voila, the triangle adds up to 180 degrees. Okay, here's exploratory challenge number 2. It says the figure below shows parallel lines L1 and L2. So I always like to label my diagram, so I'm going to put a little congruent, it looks like a boxed in arrow. Now I know L1 and L2 are parallel. Let M and N be transversals. So I'm going to color code these just so we can see them better. Okay, so here's transversal M is red, transversal N is green. It says let M and N be transversals that intersect L1 at C and B, respectively, or B and C, respectively. So M intersects L1 at B, and N intersects L1 at point C. And L2, so M and N intersect L2 at the same location, F. Okay, so they're intersecting right here. Okay. Let A be a point on L1. That's right here. To the left of B and D. So here's D, here's B, A is to the left. Let, and then what it said, to the left of B a point on L1 to the right. Okay, so it says, let me see, let A be a point on L1 to the left of B, over here. D be a point on L1 to the right of C, that's right here. G be a point L2 to the left of F. Let G be to the left of F, and let E be a point to the right of F. Okay, so they're just telling us what they're doing here. They drew two transversals across two parallel lines, and we have four other points on those lines. Okay. Now, name the triangle in the figure. So this formed a triangle right here. So this is triangle BCF. Now I can name this any way I want. It does not matter. I can call it BCF, CFB, FBC, or I can go the other way around. I can go BFC, FCB, CBF. The order does not matter in a triangle. We can name it any one of those three ways, both directions, so there's actually 6 possible names for that triangle. Okay, part B says, let's move this up. Name a straight angle that will be useful in proving that the sum of the measure of the interior angles of the triangle is 180 degrees. Okay, so we're probably going to use point F. Okay, so if we are going to work with this line here, this will help us figure out what the measure of all these angles are in here. So I'm going to call it triangle, or not triangle, angle GFE, or I could name it EFG. So it's angle GFE. Okay, so we want to show that the sum of the measures of the interior angle of a triangle are equal to the measures of the straight angle. So we're going to use what we learned before from the first exploratory challenge to find the measures of that the interior angles add up to 180 degrees. Okay, so I know that angle GFB has some measure, and I'm just going to use one arc to identify that angle. And I know that angle BFC is this angle here, okay? And angle CFE is this angle here. These 3 angles make this straight line, and we know that straight angles add up to 180 degrees. So if I just name this angle 1, and name this angle 2, and name this angle 3, then I can then say, so it says to write your proof below here. So what I would say is the measure of angle GFE equals 180 degrees. And those equal the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. So let's just take a look at that. We know GFE is a straight line, therefore it equals 180 degrees. angle 1 plus angle 2 plus angle 3 make that straight line. So the sum of those three angles is also 180 degrees. That's step 1. Okay? All right, so now I know that I have angle 1, and this angle here is also going to be equivalent to angle 1 because this is a straight line. This is a straight line, so I'm going to write that. I'm going to say L1 is parallel to L2 and line M is a transversal. So alternate interior angles are congruent. Okay, so let me recap that. I have a straight transversal going through two parallel lines, L1 and L2, and angle 1 are alternate opposite sides of the transversal inside the two parallel lines, so they're alternate interior angles. And since they're alternate interior angles, I can put a point at the midpoint, rotate either line and transversal around to F 180 degrees, and angle 1 is going to rotate over to angle 1, and therefore rotation is preserving angle measures. They are congruent. Okay, so angle 1 is parallel to angle 2, and line M is a transversal. So alternate interior angles are congruent. So that proves that this 1 is congruent to that 1. Angle 2 is already in the triangle, so it's congruent to itself, if you will. And then angle 3 is here, and angle 3 would end up here under the same rule. So this is angle 3 as well, congruent to angle 3 anyway, because these are alternate interior angles, because they're being, if we rotated at this midpoint here, this angle right here, if I rotated it around 180 degrees, it would land right here. So therefore, since L1 and L2 are parallel, so I'm going to say L1 is parallel to L2, and line N, I think it was called N, my other transversal, yes, N, line N is a transversal. So alternate interior angles are congruent. So now I know this is congruent to this, and now I have angle 1 plus angle 2 plus angle 3 is 180 degrees, because we already said that there. So then I can conclude, and 3 dots that look like a triangle means therefore. Okay, so now I'm going to name these angles. I can't just call it angle B. I'm going to say angle CBF. Therefore, angle CBF plus angle BCF plus angle CFB. That's angle 1, 2, and 3. Okay, this is angle 1, this is angle 2, and this is angle 3, equals 180 degrees. Okay, all because of alternate interior angles in straight lines. Okay, so the lesson summary says all triangles have a sum of measures of interior angles equal to 180 degrees. The proof that a triangle has a sum of measures of the interior angles equals 180 degrees is dependent upon the knowledge of a straight angle and angle relationships of parallel lines cut by transversals. Okay, so using those two in conjunction will prove this. That is the end of lesson 13. go do your problem.